chapter 17 physics, end of chapter questions, question number 10. Show that in one revolution there are 2 pi radians. So we have to go back to the basics, the definition. Angle in rad is equal to, in radians is equal to length of arc divided by radius. So now they are asking us to show that one revolution there are 2 pi radians. So one whole revolution means the arc length is then 2 pi r, right? So then the length is 2 pi r, arc length is 2 pi r divided by r. Then r to r gets cancelled out. Then the angle in radians is equal to 2 pi. So that is quite easy. Then part B, figure 17.23 shows a centrifuge used to separate solid particles suspended in a liquid of lower density. When you go to get your blood checked, you would have seen centrifuges. Centrifuge is a rotating equipment that rotates. When it rotates, the suspended materials will get separated. The solid particles will separate from the suspension. So now blood is actually a suspension. It is not exactly solution, because it is a solution in one aspect, because there are a lot of things dissolved in it. But at the same time, there are a lot of material suspended in it as well. For example, blood cells, platelets, those stuff, they are particles suspended in them. They are not dissolved in it. So in this suspension, to separate these solid particles from the suspension, you use a centrifuge. Now this centrifuge is spun at a rate of 540 revolutions per minute, right? 540 revolutions per minute. So you can actually find out the frequency, that is how many times it rotates in a single second. You divide it by 60, right? So now the first question is, can calculate the angular velocity of the container. Calculate the angular velocity of the container. So now you have to use the equation omega equals frequency into 2 pi. So that equation, let's do it here. Omega equals frequency into 2 pi. So frequency is 540 divided by 60 multiplied by 2 pi. So when you do this, you will get omega to be 56.5 rads per second. 56.5 rads per second. All right. Then part 2, calculate the centripetal force on a particle of mass 20 milligrams at the end of the test tube. 20 milligrams. So be very careful, because milligram, when converted into grams, first of all you have to multiply it by 10 to the power minus 3. Then grams into kilograms, you have to multiply it by another 10 to the power minus 3. So that is 10 to the power minus 6 is the multiplication. So let's do that. So the equation is F equals, they have given the mass, they have given the radius, mr, and omega squared we found. So in this particular situation, F stands for the centripetal force. That is what we are trying to find. Centripetal force is equal to, mass is equal to 20 into 10 to the power minus 6. Then R is, because this is 10 centimeters, it would be 0.1 multiplied by, we found the omega, omega was 56.5, and that has to be squared. When you simplify this, you will get the answer to be 0.0 0.0 0.064 newtons. 0.0064 newtons. Right. Then part C, an alternative method of separating the particles from the liquid is to allow them to settle to the bottom of a stationary container under gravity. By comparing the force involved, explain why the centrifuge is more effective method of separating the mixture. So now the gravitational force is going to be, we have to find out the gravitational force, that is mg. So mass to be taken in kilograms, so that would be 20 into 10 to the power minus 6 into 10. That would be 0.00002. So that is very much less than the centripetal force that is needed. So as a result, the centrifuge is going to be really fast. It's going to be quite fast, effective. I hope you understood, and that is the end of chapter 17. If you have any questions, please raise them. Yes, thank you.